Evening, brothers and sisters. What you're looking at here is how Polaris works on the flat Earth with Antarctica, which is the true, and I'm going to repeat it, true North Pole. Now, I highlighted the equator in red because inside here, inside the red wheel, I'm going to say here, you cannot see Polaris. Okay? Now that we have that out of the way, we understand now that the sun is traveling around the flat earth above. One side is going to be at night. You have to understand that Polaris is, you can say, being propagated out from the North Pole this way in both these directions. So when it's night on this side, let's say, you see Polaris. When it's night on this side, you see Polaris. The stars of Polaris always rise from the east to the west. Okay? Now, if you're standing here above the equator, you'll still see Polaris. You still see it from here. All right, now this example here is a better example. This works exactly the way the flat Earth works. This represents the electromagnetic energy grid, energy field, the dome of the Earth, the heavens. This is the equator. Inside here, it's not possible to see Polaris. This is Polaris. Now, this is how the radiation propagates out from a dipole antenna, a bow tie dipole, and this is what the flat Earth is. This would give you the image that everybody sees in the North Pole of Polaris. It's not the North Pole. The North Pole is the circle of the Earth. I'm going to show you a better example of what I mean, of how this works. Now, this is exactly how the energy propagates out from Antarctica, the North Pole, the true North Pole. It's too fast to see it change. It moves like the speed of light. This is the electromagnetic field that produces the image of the celestial sphere on the dome of the firmament. This is the best example I can find to show you what I mean. Polaris. Draw the pole through here. An axis. Inside here would be the equator. You have to understand light bending, electromagnetism, electromagnetic radiation. Now this is radiation from an oscillating dipole, oscillating out this way and this way. So as you can see, that is how you see Polaris on the flat Earth. This is another great example here. The electric field is up, the magnetic field is this way. This is how it propagates up towards the dome. Now, if you're anywhere inside the equator, like I'm going to say again, you can't see it. You can't not see Polaris inside this area here. Instead, you see what appears to be your South Pole, what you believe was the South Pole. Why they believe, many people tell you that the South Pole has no star. This is the South Pole. This is the North Pole, the circle of the Earth. let's draw a circle around it to make it, to give it better understanding of what I mean. This is kind of what I mean here. It just, I couldn't get the circle to fit, but you know what I mean. Polaris. It bends on the dome. But inside the equator here, inside you won't see it anymore. You see this. This is how Polaris is projected out. And if you're inside here, the equator, you won't see this. Another great example. The equator. Polaris. As you approach the equator, Polaris falls on the horizon until you hit the equator and it's absolutely at the horizon. Once you go past it, you no longer see it. Once you go past the equator, you no longer can see Polaris on a flat Earth. This is how it would look as you get further and further away from the dome and closer to the equator and then passing the equator. You don't see it anymore. This is the dome. Your zenith. Antarctica is the center of the flat Earth. Some people will say, are there two? So you're saying there's two polarises. I'm not saying that. I'm just saying that the energy is just being propagated out. The Earth is not moving. Only the celestial sphere appears to be moving. It appears to be moving. So for now, I'm just going to leave it at that. Peace and blessings, brothers and sisters.